Improving, Lakshmi Ram. Thank you so much for asking me. Better than yesterday. Not totally fit yet. Still some throat congestion, but better than yesterday. Okay. Good evening, everybody. Hello. Good evening, all of you. All YouTube people. Good evening. Good evening, Zoom people. Hello, everybody. Can everyone see me and hear me properly? Am I audible and visible? Your voice changed, yes. I have a bad throat actually. It will be fine soon, don't worry. Good evening. Good evening, guys. Okay, shall we start? So yesterday we have discussed about the very important concept. Hi everyone on YouTube, good evening guys. Zenith, it's much better. So we'll talk about some of the things regarding limiting reagent today. So very quickly we'll do a hello everyone. Hi Lenny, hello. Good evening everybody. Okay. Everybody's here, all of you? Good. Hi everybody, good evening. Did you have your snacks, sir? Yes, I had a cup of tea before coming over here. Thank you so much. So guys, yesterday we were discussing about limiting reagent. If you remember. So over there I told you that suppose A plus 2B goes to 4C. Just a quick recap of what we have done. Na2SO4 question, okay, I'll explain that. Yeah, don't worry. So let me first go into limiting reagent. We have to discuss some important things related to limiting reagent today. All right. So A plus 2B goes to 4C. This is the reaction. And yesterday I said that whenever the ratio of initial moles, like let's say this is 1 mole and this is 5 mole. Okay. So whenever the ratio of initial moles and the stoichiometric coefficients, what is the ratio of initial moles over here? It's 1:5. And what is the ratio of stoichiometric coefficients? It's 1:2. So clearly we can see over here that both the ratios are what? They are different from one another. The ratio of initial moles and the ratio of stoichiometric coefficients are not same. They are not same. So this means that reactants have not been taken in the same ratio in which they are going to be consumed. I hope you remember that pen example I gave you, that body of pen and 2 caps. So ideal situation should be that for every body there should be 2 caps. Okay. But whenever this trend will break, then what will happen is that one of the reagents will be completely consumed. So in this case, this A was the limiting reagent, LR stands for limiting reagent, okay, and my dear friends, this B is the ER, which is the excess reagent. All right. And a very important thing which we discussed was that moles of limiting reagent must be calculated. Moles of product should be calculated from the moles of limiting reagent only. Okay, we should apply grandpa equation on the limiting reagent and the product in order to calculate that how much of product will be formed. Okay. So now let us move forward. Yes, Pawan, we are going to deal with those cases today. Okay. So now the next question is that this is what we have covered yesterday. Okay. So now we are going to talk about that, Pranti. Now we have to discuss how to identify limiting reagent. This is what we are going to discuss. How to identify limiting reagent. See, in the previous example, the one which I took, you identified limiting reagent by common sense. Like you said, okay, for 1 mole of A, 2 mole B needed. But for 1 mole of A, I have taken 5 mole. So if I have taken 5 mole means I have taken B more than required. So B became excess reagent and A became limiting reagent. This was pure common sense. Okay. But this common sense may not be that common if I twist the data a little bit. If I twist the data a little bit, this common sense may not be that common. Okay? Like for example, suppose if I tell you the least mole is SR, no Sudeshna, that is absolutely wrong. Please don't use that, otherwise you will yourself get confused and others will also get confused. No. First of all, let us see some situations. Don't write it down right now. Okay? Now A plus 2B goes to 4C. A plus 2B goes to 4C. Suppose if I start with 2 mole of A and 3 mole of B. 2 mole of A plus 3 mole of B. Another example. A plus 2B plus 3C goes to product. Some product is being formed. Okay? I start with 2 mole A, 3 mole B and 4 mole C. Now, who is the excess reagent over here? Some of you might have this feeling, sir, both are excess. No, not at all, my dear friends. When this ratio and this ratio are different, there is one reagent which is limiting and the other is excess. First, get this firmly fixed in your head. PDT is any product. PDT stands for any product. We are not interested in that right now. PDT represents any product. Okay? So this ratio is 2:3 and this ratio is 1:2. Similarly, this ratio is 2:3:4 and this is 1:2:3. So whenever the ratios of initial moles and stoichiometric coefficient are different, okay, then only one reagent is limiting reagent. You can't say that both reagents are limiting. Like for example, if I give you 2A plus 3B plus 4C goes to some products, any products, and I tell you I start with 1 mole of A, 2 mole of B and 3 mole of C. Now tell me who is the limiting reagent? In this case, which is the limiting reagent? In this case, which is the limiting reagent? Now it is not becoming that obvious now. I hope you are able to understand the situation. I hope you are able to understand the situation. And who is the limiting reagent in this case? Who is the limiting reagent in this case? In this case, who is the limiting reagent? No. It is B, it is not A. Now let me teach you how to. So the point which I am trying to emphasize over here is that who is the limiting reagent? We cannot leave this to luck, na? We will say, okay, sir, if on the NEET exam day, God is with me, then I will be able to identify the limiting reagent. We need to have a foolproof sure shot method. You understand that, everybody? So that we can be 100% guaranteed. There is no guesswork. Feeling wala game nahi hona chahiye. Ki sir, I feel that A is limiting reagent. I have this gut feeling that B is the limiting reagent. Okay? So we are talking about science over here, not gut feeling, right? So we need to have a proper foolproof method in order to identify what is the limiting reagent. So let me teach you how to identify the limiting reagent first, and then I will come back to these examples and you will yourself find out the limiting reagent. Is this clear, everyone? We are going to discuss a sure shot 100% guaranteed method. Sure shot 100% guaranteed method in order to find out the limiting reagent so that we can say with surety. No guesswork. Feeling ka game nahi hai ye. Sir, I was feeling good that day, so I have this feeling. Okay, that very famous song is there, na? Tonight's gonna be a good night. Okay, I have this feeling. So I have this feeling that A is the limiting reagent. I have this feeling that B is the limiting reagent. It's not about feelings; it's about numbers. So let's focus on that. Okay. So, my dear boys and girls, how to identify the limiting reagent? Suppose there is a reaction AA plus BB plus CC plus DD plus dot goes to product. Any number of reagents can be there. Okay? Can there be more than one? Pawan, we will address all those cases. Have patience. Let me cover this first. Okay? AA plus BB plus CC plus DD goes to product. Okay? This is the reaction. Step one is calculate moles of all reactants. calculate moles of all reactants. Now in the question, of course you have to write this, na? Then after this you will come back to those questions and then you will solve those questions. This you have to write, or you can understand it also. Step 1 is calculate moles of all reactants. Now in the question which I gave you, the examples which I took earlier, I had directly given you the moles. Okay, but it may be possible that directly moles are not given. Mass is given or volume at NTP is given. So your first task is to convert everything into moles. Is this clear, everybody? If directly moles is given, like in these cases, very good, balle balle, we are happy. But if moles is not given, mass is given or volume is given, our first step would be to calculate the moles. Okay, so first step is calculate moles of all the reactants. If they are directly given, very good. If not, then you will calculate it. Okay. Now, then after this, step 2 is that sorry. Step 2 is that calculate moles of A upon A, moles of B upon B, and dot. Basically, calculate. See, this is the immense. That is, there is a reason why I called the grandpa equation as the grandpa equation. It is giving answer to each and everything. Calculate moles upon stoichiometric for all the reactants. Calculate moles upon stoichiometric for all the reactants. For each and every reactant, calculate moles upon stoichiometric. Now, in a balanced chemical equation, these moles upon stoichiometric were equal. But if you disturb the ratio, then they will not come out to be equal. They will come out to be different numbers. So that particular reactant for which this fraction is minimum, least value, that particular reactant for which this fraction is minimum, that reactant will be your limiting reactant. Because that means that that particular reactant has been taken in the least amount as per the requirement. You don't just have to look at the least amount, you have to look at the least amount as per the requirement. So this moles of A upon A, moles of B upon B, moles of C upon C, you will calculate like this for all the reactants. And step 3 is the reactant having minimum value. The reactant having minimum value of above fraction. The reactant having minimum value of above fraction will be limiting reagent. The one which has the minimum value of this fraction will be the limiting reagent. Is this clear, boys and girls? Arey bhai, you will calculate the fraction like this for everybody. So that place where the fraction is minimum, least value of the fraction, that reagent will be the limiting reagent. Quickly note it down. Let's apply this in some situations. Let's apply this. This is how you can tell limiting reagent with surety and not on the basis of feelings. Okay? Feelings don't fetch you marks. Processes get you marks. Good exam. Quickly note this down, everybody. Those who have written, quickly write C in the chat box. Omkar bhai, if maximum it is excess reagent. Yes, Omkar garu. Absolutely correct. Yagnan Ram, Na2SO4 question I will explain, don't worry. But we don't want to identify the excess now. What is important? Limiting is important. Chaliye. So now everybody, note down this first question. Okay, note down this first question. Note down this question number 1 and try to find out the limiting reagent over here. I'll just make some space. So 2 mole and 3 mole. If you have already written it, no problem. If you have not, so now find the limiting reagent. Now find the limiting reagent is this example number 1. So Deshna, we will see to that. Step 3 is better the one which is having minimum value of above fraction will be the limiting reagent. Everyone has noted this, na? So now listen to me, bhai, everyone. So this was the question, okay? So what we have to do over here is moles of A upon A, 2 upon 1. Moles of B upon B, 3 upon 2. Which is smaller? Look at this number. This is 2. And 3 by 2 is how much, guys? 1.5. This is 2. This is 1.5. Which is smaller? 2 is smaller or 1.5 is smaller? 2 is smaller. 2 और 1.5 में छोटा नंबर कौन सा है? 1.5 is smaller, ना बेटा? This is 2 by 1. This is 3 by 2. So 1.5 is smaller, na? Arey, mole of A upon A, mole of B upon B. So 1.5 is smaller. So therefore B is the limiting reagent and A is the excess reagent. A is the excess reagent. B is the limiting reagent, A is the excess reagent. Is the first example clear, everybody? B is limiting, A is excess. चलिए, let's come to example number 2. Example number 2. Moles of A upon A, 2 by 1. Moles of B upon B, 3 by 2. Moles of C upon C, 4 by 3. Which is smallest? 2 by 1 is equals to 2. 3 by 2, 1.5. And 4 by 3 is 1.33. So which is smallest, bachcho? C is the limiting reagent. C is the limiting reagent. And A and B both are excess reagents. A is also excess, B is also excess. They both will be left. Beta, first step was to calculate the moles, Pujita. And after that, what was the next step? Okay, where is that slide? 1 minute. First step was to calculate the moles. And then after that, moles of A upon A, moles of B upon B. Once you get this, then you decide on the limiting reagent. Okay, you have to calculate the fraction. So C is limiting, A and B are excess. Is this okay, everyone? Understood, all of you, bachcho? Chalo, next example. Next example. Are Bhavya, wait, all examples will come. How to calculate moles? Beta, given mass by molar mass. If it is a gas, then given volume at NTP divided by 22.4. We will do all examples. Chaliye, over here. Tell me quickly. Moles of A upon A. Moles of, this is example 3. Moles of B upon B. Moles of C upon C. 1 by 2, 2 by 3, 3 by 4. Only task was to identify limiting reagent. 1 by 2, how much? Moles of A upon A, moles of B upon B, moles of C upon C. 1 by 2, 0.5. 2 by 3, 0.66. 3 by 4, 0.75. So out of these three numbers, which is smallest? 0.5 is smallest. So what will be our answer? A limiting B comma C excess. A limiting B comma C excess. With sure shot guarantee we can say. Let's take some more examples. Let's take some more examples. Note it down, everybody. Complete this quickly. Noted, everyone? Completed, right? See if you have done it. Devki, whenever I ask who is the limiting reagent, you will just say AB, not 2A or 3B like that. Coefficient will not be needed. You will just write A, B or C. You will just write the name of the reagent. 2 is the coefficient in the balancing. Reagent is A. Okay? Chalo, next example. Number 4. 2A plus 3B plus 4C goes to some products. Okay? And we have started with 6 moles of A, 9 moles of B, and 15 moles of C. Now let us calculate the fraction. Moles of A upon A, 6 upon 2. Moles of B upon B, 9 upon 3. Moles of C upon C, 15 upon 4. 6 by 2 is how much? 3. 9 by 3 is how much? 3. And 15 by 4 will be 3.75, more than 3. So this time there are minimum value is 3 and there are 2 reagents corresponding to that value. So both of them will be limiting reagent. Both A and B will be consumed. Yes, okay. So both will be limiting reagent. Both will be limiting reagent. And in order to calculate the product, you can either use A or you can use B. Both A and B are limiting reagent. Both A and B are limiting reagent and C is the excess reagent in this case. Okay. So A comma B. I hope this is the doubt some of you were asking some time back. Sudeshna and some more people. नहीं यार, it will be प्रीतम कैसी बात कर रहे हो? ये क्वेश्चन में गिवन होगा ना बेटा. How can it be our wish? We have to solve the question, not make the question. This will be given in the question that what is the initial moles. I think this was the doubt some of you had some time back. I hope it is clear now. So A and B both are limiting reagents and C is what? Excess reagent. Okay, Pawan Kumar, you also asked the same doubt. On YouTube, is this clear, everybody? Sorry. Okay, very good. Thank you, Manyan. Shall we move forward, everybody? Shall we move forward? Okay. Chalo, next is C plus O2 goes to CO2 equal mass of C and O2 are taken. Equal mass of C and O2 are taken. Equal mass. Find LR. Find LR. Equal mass of C and O2 are taken. Find LR. Equal mass. Both are LR? No, that is not possible. See, how will we do this? Let's try to understand. Equal masses are taken. So equal masses means you can take 1 gram, 2 gram, x gram, whatever makes you happy. Whatever makes you happy. Okay. So let's say we take 1 gram and 1 gram. Let's say we take 1 gram and 1 gram. Now this time moles is not given. This time what is given? Mass is given. First step will be to convert into moles. First step will be to convert into moles. How do we convert into moles? Given mass upon molar mass. Molar mass of carbon is 12. Given mass upon molar mass. Molar mass of O2 is 32 ma'am, not 16. 32 यार O2 है. 16 plus 16. Not 16, 32. So given mass by molar mass. This is the moles. This is the moles of carbon. This is the moles of oxygen. And now you will do moles of A upon A. So coefficient is 1. Coefficient is 1. So it will remain same only. Moles of A upon A. So it will remain same only. Moles of B upon B. Here also coefficient is 1. So it will remain same only. So from 1 by 12 and 1 by 32, who is smaller? 1 by 12 and 1 by 32, who is smaller? I hope you know that the one with the bigger denominator will be the smaller number. So therefore O2 is limiting and carbon is excess. O2 is limiting and carbon is excess. O2 limiting, carbon excess is your answer. Understood everyone? Everybody clear? Yes, oxygen is LR. अभी ऐसे भविष्यवाणी मत क्या करो यार. क्या मैं साइंस पढ़ रहे हो, कोई एस्ट्रोलॉजी सीख रहे हो क्या? मतलब why do you want me to give an answer to this question? In every reaction there is at least one LR. We are studying chemistry, not astrology. That will depend on the situation. Because CO2 is not a reactant, CO2 is a product. In this question, CO2 is not needed. Okay, next question. Is everybody ready? What happens to ER? It is left over. It is not consumed. It remains after the reaction. This is the definition of ER. Okay, next question. Chalo. Next question is 2 Mg plus O2 goes to 2 MgO. 2 Mg plus O2 goes to 2 MgO. Equal mass of Mg and O2 are taken. Equal mass of Mg and O2 are taken. Find LR. Do this everybody. Equal mass 2 Mg plus O2 goes to 2 MgO. Equal mass of Mg and O2 are taken. Find LR. Equal mass of Mg and O2 are taken. Find LR. Equal mass of Mg and O2 are taken. Find LR. Note down the question quickly, everyone. Who is the LR by Mg or O2? Most of you have got it right. See, 2 Mg plus O2 goes to 2 MgO. Initially we have taken equal mass. So let us say 1 gram, 1 gram. Or you can say x gram also, whatever. Okay. Now you will calculate the moles. So 1 upon molar mass of Mg is 24. So 1 upon 24 given mass by molar mass. And 1 upon O2 molar mass is 32. But don't jump to the answer looking at this only. This is moles. Given mass upon mg molar mass is 24 and given mass upon O2 molar mass is 34. Now you have to calculate the fraction also. Fraction. Moles of A upon A. Moles of A upon A. So 1 upon 24 divided by 2. 1 upon 24 divided by 2. This is what you will get. Moles of A upon A. 1 upon 24 divided by 2. And moles of B upon B. So 1 upon 32 and divided by 1 will remain same only. So now you can see this becomes how much? 1 upon 48. And this is how much, Bacho? This is this is 32. This is 48. This is smaller. 1 upon 48. Denominator is more, so the value will be less. So this is smaller. So Mg is the limiting reagent and O2 is the excess reagent. Mg is the limiting reagent and O2 is the excess reagent. Is this understood, everyone? Harshvardhan, we will not say 2 Mg, we will only say Mg. 2 is the coefficient of Mg. Mg is the limiting reagent. We will not say 2 Mg is the limiting reagent. 2 Mg is not a reagent. 2 Mg is the coefficient. Mg is the reagent. 2 is the coefficient. Okay, is this clear? Next question, everyone. Next question, everybody. All of you ready? Okay, next question. Chalo, ठीक है. Next question. 4Al plus 3O2 goes to 2Al2O3. Once again, equal mass of Al and O2 taken. Find limiting reagent. Equal mass of Al and O2 taken. Find limiting reagent. Equal mass of Al and O2 taken. Find limiting reagent. Do it, everybody. Let's have a look at this problem. So 4Al plus 3O2 goes to 2Al2O3. Chalo guys, what will we do over here? Initially equal masses are taken. So that can be taken as anything, 1 gram, 2 gram, 1 crore gram, 1 crore gram, 10 crore gram, 10 crore gram. But let's take a cube number, 1 gram and 1 gram. Cube number. Cube numbers are very welcome. Now, then the step will be to calculate moles. So aluminium molar mass, boys and girls, is 27. So 1 upon 27. 1 upon 27. And O2 molar mass is 32. So 1 upon 32. Given mass by molar mass. Given mass by molar mass. And now you go for the fraction. Moles of A upon A. So 1 upon 27 into 4. Moles of A upon A. And moles of B upon B. 1 upon 32 into 3. So this is 1 upon 108, 27 into 4. And this is 1 upon 96. So which is smaller, boys and girls? Very good, very good. See, everyone is moving forward in life at a very fast pace. Just see the difference created in your knowledge in 2 days. Till yesterday, you did not know that there could be something of the type of limiting reagent. And 24 hours later, You are finding out who is the limiting reagent in such complex situations. Very good, very good. Al, Lr, O2, Er. Okay, quickly note it down. Last question of this type, then we will move forward. Next type of question. Note it down quickly. Those who have written right, see quickly in the chat box. Chalo, next one. Chalo, be careful with this. S plus O2 goes to SO2. Equal mass of S and O2 are taken. Equal mass of. Android, can you please tell me previous question once again? Beta, previous question में 1 gram, then calculate moles. So 1/27 aluminium molar mass, 32 mole. Okay. Android, beta, all are similar examples. Okay. So anyone you have understood, the meaning you can try after the class also. Equal mass of S and O2 are taken. Find LR. Okay, find LR. Equal mass of S and O2 are taken. Find LR. Both or none. See, we should use the word when you are using limiting, then there must be at least one which is in excess, na? By here the ratio of stoichiometric coefficient is same as the ratio of initial moles. So therefore the precise answer is not both. The precise answer is no limiting reagent. No limiting reagent, because we should use the word limiting only. If I am using the word limiting, then there must be at least one of them in excess, na? Limiting word should be used when at least one is in excess. Then no limiting reagent. Both will be totally consumed. See everybody, pay attention. S plus O2 goes to SO2. Okay? 1 gram sulfur, 1 gram O2. Now you will calculate the moles. 1/32. 1/32. 1/32 by 1. 1/32 by 1. So both ratios are coming out to be same. Ratio of stoichiometric coefficients is also 1:1 and initial moles is also 1:1. One and the same thing. Yes, Sudeshna. Absolutely. We don't have to calculate, so we just take 1/32. Both are same. So both are same. So we will say that, see, we should use the word limiting when at least one is in excess. Here nothing is in excess. So our answer is no LR. No limiting reagent. Both are totally confused. Limiting word should be used only when at least one is in excess. Limiting word should be used only when at least one is in excess. Otherwise, there is no significance of limiting reagent. Okay? So let's practice some more problems. Let's have a look at some more problems. Okay? No limiting reagent over here. 1 minute. Chaliye, do this. BaCN2 is mixed with Na3PO4. Thank you, M. Siva. To give you Ba3PO4 whole twice plus NaCl. Equation is not balanced. Equation is not balanced. Please note this. You have to balance it first. 0.5 mole BaCl2 is mixed with 0.2 mole Na3PO4. Find moles of Ba3PO4 whole twice formed. So here you have to apply. First you have to balance, then you have to find limiting, then you have to apply grandpa equation on limiting and product to get the moles of product formed. Do it, everybody, try it. Let's have a look at the answer. So on Sunday exam is there. Barium mass not needed, Anya. I have given you moles straight away. Mass of barium not needed, but it is 137, I guess. No, barium is most probably 137. Atomic mass of barium 137 only, but not needed in this question. Exam on Sunday. I'm not sure about that because like Sunday meet is there. So let's see if it is there. You'll be informed. So first of all, we will have to balance the equation, boys and girls. So balancing will be done. 3 barium. So I put a 3 over here. Then after this 2 phosphate. So I put a 2 over here. And now this becomes 2 3s are 6 sodium and 3 2s are 6 chlorine. So I put 6 over here. This is the balanced equation. Now barium chloride is how much? Question is noted, I hope everybody. So I am removing this. Barium chloride is 0.5 mole and sodium phosphate is 0.2 mole. Okay. So this is the initial amount. Now we have to find the limiting reagent. So 0.5 upon 3, 0.5 upon 3 and 0.2 upon 2. 0.2 upon 2. So clearly this is smaller. So this will be more than 0.1 na? So this is the limiting reagent. I am writing it over here, limiting reagent. Okay. So now in order to calculate the product, let us say product is X mole. So you will apply grandpa equation on limiting reagent and product. Grandpa on limiting reagent and product. So 0.2 upon 2, 0.2 upon 2 is equals to X upon 1. So X is equals to how much? 0.1 mole is the answer. Well done, my dear kids. Very, very good. How 0.2 mole came? And it was given in the question here. Question I had said, na, Bhavya, 0.2 mole of Na3PO4. It was written in the question only, beta. So 0.2 mole was written in the question. Okay? Understood? All clear, guys, everyone? Okay. So 0.1 mole will be the answer. So I am leaving you with one homework question, okay? Tomorrow, I guess most probably it will be our last class. So we will be winding up this topic tomorrow. Okay? So I'll be giving you one homework question. All right. We will discuss that tomorrow. Okay. So 2H2 plus O2 goes to 2H2O. This reaction is happening. 4 gram H2 is mixed with 4 gram O2. Find mass of water produced. Find mass of water produced. Last class as in online, na? I think so, I'm not sure. Four gram H2 is mixed with 4 gram O2. Find mass of water produced. Okay. This is the previous slide. Alright, my dear friends, so that will be all for today. Very quickly, I'll share the QR code with you. I'm doing that, don't worry. Offline classes will start in this month only, Redmi. It will be notified, don't worry. What? I missed the message of that grandfather. Do we have classes again from Monday? I don't know about that. Will always we have to. Only in the limiting reagent. Okay? Only in the limiting reagent. Oh, Yagnan, I'm very sorry. Tomorrow, before starting the class, I will explain you the sodium sulfate question. Don't worry. Okay, Yagnan? Are you happy? Tomorrow, before I start with the class, I will explain you that sodium sulfate question. QR code is already zoomed. It can be zoomed further. Okay? Chalo guys. Bye-bye, bye-bye. Pleasure teaching you all. Really happy to see the progress you are making every day. And these were some very good questions, and I'm really glad that you could calculate the answers to them very fast. Okay? Really happy for you. Keep working hard. You are hitting the right spots. You just have to take it step by step. Well done, very good. No, all progress is because of you only. I am only the medium. Okay, you are the reactant and the product. I am the solvent. I am just helping you in the reaction. The reaction has to be done by you only. I am only the medium, solvent which will facilitate your reaction. Chalo, bye everybody. Bye guys, bye. Pleasure talking to you all. Have a good day everybody. Thank you, beta. Chenuru, thank you so much. Appreciate that. Thanks a lot.